Okay, so we're going to be looking at differentiation and integration. Now, just a fair warning, I'm only going to be telling you the basic things and then picking a few things out to tell you enough so that you can answer a specific type of question. If you want to learn more in detail, I recommend checking out Mr. Bison's channel if you're passionate about math. Okay, so first I'm going to explain what differentiation is. So differentiation is the process of finding the rate at which a function changes with respect to the variable, basically the gradient. So basically we find the gradient at specific points on the graph. Now usually we're used to finding the gradients of a curve by using tangents. But tangents aren't accurate, so we differentiate our equations, we have some rules and all of that, so we do that, and then we can plug in the x value or sometimes y value as well to find the gradient, right? So there are many types of differentiation and there's a lot of stuff, but I think this is a good definition to start with. It's just us finding the gradient of the curve by using a set of rules that we have, and that's how we do that. And integration is the opposite of that. So we find the area beneath the curve. Okay, so if you want to find the area beneath the curve, you're going to integrate, because for this type of curve, your normal rectangle, triangles aren't going to work. So when those fail, you're going to use integration. So integration is the process of finding the accumulated quantity or the area under a curve. So here also we have got a lot of rules and stuff that people who take math will learn in their A2 level. So if you want to learn it like this, you can just learn that differentiation is us finding gradient, and then integration is going to be us finding the area beneath the curve. Okay, now we're going to be looking at the differentiation and integration of sine x and cos x. So you're going to have to memorize this. Alright, so the differentiation of sine x, we're going to differentiate it. We're going to get cos x. And for cos x, if we differentiate it, we get minus sine x. Okay, so I hope this is clear. This is the first thing. Okay, I'll explain more of that diagram in a bit, but first you have to understand this rule. Okay, next, the integration of sine x, so you're going to integrate it, is going to be minus cos x. Okay, and then the integration of cos x, so you're going to integrate it, you're going to get sine x. Okay, so I hope you have just seen those rules. I'll tell you how to memorize them properly. Now I'm going to tell you a bit more about integration and differentiation. So remember, integration is the reverse of differentiation. So let's take the first example. If I take sine x and I differentiate it, that's what we saw first, I'm going to get cos x. So I have differentiated. If I'm integrating, I'm going to do the reverse, right? And that's why when we differentiate sine x, we get cos x. And when we take cos x and we integrate it, we get sine x. Okay, so they're kind of the reverse of each other. So sine x, we get cos x, and then we integrate cos x, we come back to sine x. Okay, now let's talk about cos x. So when we differentiate cos x, I'm going to get minus sine x. Okay, now I know if you're watching this video, you're going to be very confused with all of these things, but you don't have to memorize all of this right now. I'm going to tell you how to memorize it. That's why we have the diagram above. I just want you to see, just observe what's happening. Okay, so we're going to get minus sine x. And then if I integrate minus sine x, I'm going to get cos x. Okay, so if someone asks you, we have minus sine x and we integrate it, what are we going to get? You have to think about the reverse, right? If we differentiate cos x, we're getting minus sine x. So if I integrate minus sine x, I'm going to go reverse, so I'm going to get cos x. So you should get cos x. Okay, now look at this very carefully. Let's take an example of minus cos x. If I differentiate minus cos x, I'm going to get minus sine x, right? So differentiation of cos x is going to be minus sine x, and then we have the minus sign in front staying there. And then minus becomes plus. So I'm going to be left with sine x. Now if I do the reverse of this, if I integrate sine x, I'm going to get minus cos x. So if someone asks you, what's the integration of sine x, you're going to say, that's going to be minus cos x. Okay, so these are kind of the way we understand differentiation and integration. So I hope this point is clear, right? I'm doing all of this just to explain you this point. Okay, so we've got a table here. So you're going to put sine x here, minus sine x here, minus cos x here, and cos x here, right? Now, going clockwise equals differentiation. Going anti-clockwise is going to be integration. Okay, so clockwise, differentiation, and then going anti-clockwise is integration, right? Now, I know this will not click in until we do a few questions. So let's do a few questions and see how this works. So I've got two exercises here, and we're going to be using that table that we drew. So we're going to write sine x here. We're going to write minus sine x here. I'm going to write cos x here and minus cos x here. Okay, now let's see how we go about this. Now the rule was clockwise is differentiation, anti-clockwise is integration. And the reason they're opposite directions is because we discussed, right? The integration is the reverse of differentiation, so that's why it goes like that. Okay, so now we're going to be looking at these four questions that we have got. So sine x, if I differentiate it, so sine x, if I differentiate it clockwise, I'm going to get cos x. If I differentiate cos x, I'm going to get minus sine x. If I differentiate minus sine x, I'm going to get minus cos x. If I differentiate minus cos x, I'm going to get sine x. So I know this is very easy with this diagram. If you memorize the rules, it might take a lot more practice. So make sure, even for math students, if you haven't started your P3 math yet, then this is really good and helpful. So the last one is going to be the exercise on integrate the following. So we've got these four. Again, I'm going to do the same thing again. We're going to write sine x, minus sine x, cos x, and minus cos x. And this time it's going to be anti-clockwise. Integration, we won't be needing differentiation now. We've already done the exercise for that. So sine x, we go anti-clockwise. That's going to be minus cos x. Cos x is going to be right over here. So I'm going to go anti-clockwise. So it's going to be like this. So sine x, and then minus sine x is going to be again anti-clockwise. That's going to give me cos x, and then minus cos x anti-clockwise. That's going to give me minus sine x. Okay, so that's how you do this. It's just remembering the directions, and the rest is really easy. So that's all. Now in the next video we're going to be going through applying this to the kinematic graphs. Okay, so before we go further, I just want to let this be a quick refresher about sine x and minus sine x graph. So sine x graph, we already know. I hope you're familiar with that. Minus sine x is basically the graph being reflected along the x-axis. So along the x-axis, you're going to flip everything, right? So I'm going to flip. So it's going to be looking something like this, right? So this is going to be the minus sine x graph, and that's right over here. Alright, now let's talk about cos x and minus cos x graph. Same thing here, you're going to flip the graph. When you multiply it by minus, you flip it on the x-axis. So it's going to be the same thing, but just flipped. Right? So that's going to be your minus cos x graph. I just want you to look at them and make sure you're familiar with these. Okay, so sin x minus sin x graph, and cos x and minus cos x graph.